aim and objective of this experiment, it is to learn to use the multimeter, signal generator, and the CRO. Display and measure AC signal parameters using the CRO, and then measure the AC voltage using multimeter and compare it with the measured value from the CRO. The, the apparatus and equipment required in this experiment, we have the CRO. This is the cathode ray oscilloscope. This is the digital multitester, and this is function generator. So first thing to do, we will focus with the principle behind or the connections on how to operate the cathode ray oscilloscope. So this is the logic proof of CRO. We have the scale of times 1 here and times 10. As far as CRO is concerned, we need to calibrate first. What is the reason, by the way, why do we need to calibrate the CRO? To get the accurate reading and correct measurement. That is the purpose of the calibration. So we will turn on the CRO. We will turn on, and then we have a channel 1. This is actually a channel 1, and then this is channel 2. So as far as channel 1 is concerned, you will observe that there is a line here. When we will locate it to channel 2, this is actually channel 2. Both channel, it means it is a dual. So this is considered as channel 1, and then this is channel 2. Then we will insert this logic probe to channel 1. Then we just locate this parameter into channel 1 only. So we have now the focusing position, but we need to calibrate first. So we need to insert the positive test rod of this logic probe here, and then we will put it into equivalent volts per division 1. 1, and then also here should be in 1. Then point it into ground, so we have now one line here. So as far as the intensity is concerned here, it is the brightness, meaning make it visible like this. So as what is important here, it is a visible for you. This is the intensity, this is the adjustment for the focus. So you need to focus it with equivalent visibility or visible for you. And then at night, you can use this light as the illumination or illuminance. Okay, so there is a light at night. You can use this light for the illumination. Okay, then the position, we have the vertical or the x-axis. This is the x-axis, and then this is the y-axis. We have the number per division. So per division, it composed of 1, 2, 3, 4, 5, 6, 7, 8 in y-axis, and then in x-axis we have also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then with respect to y-axis, if this is per division, this is subdivision. It composed of 5, so it is 0.2, 0.4, 0.6, 0.8, 1. So this is one division, this is subdivision. Then we have to connect the CRO to the digital multimeter and then function generator. So first thing to do it is to turn off the CRO for safety purposes. Then let us consider the procedure in our connections. So as stated in the schematic diagram, we need to connect positive from positive of the voltmeter. This is the voltmeter. It composed of voltmeter AC, alternating current, 2 volts, 20, 200, maximum of 750. And then with DC voltage, we have 2 volts, 20, 200, and 1000. The difference between voltage alternating current and voltage direct current, the polarity here, it is alternative, meaning it is either positive or negative, and here it is a fixed polarity for positive and negative. So we will use this wire as positive and this wire for our common or negative. So we will insert to the digital multitester here. So it is now our positive. And then this one here in common, it serves as negative. Then this is the function generator, meaning we will connect the equivalent positive with respect to positive of the of function generator and positive polarity of the digital multimeter. Why multimeter? Why this is multimeter? Because multitask. You can measure the voltage, you can measure the current, you can measure the resistance. But in this experiment, we just focus on AC voltage. Now, this is the positive with respect to positive, and then negative with respect to negative. So as you've noticed here, so after connecting the wire from function generator to digital multitester, we can now connect also the equivalent of logic probe of the CRO. Now we will connect negative, of course, to the equivalent value of negative, and then the positive, we will connect it also with the equivalent positive here from the CRO. So for safety reason, make sure that in doing the connection, the CRO, voltmeter, and even function generator should be in off condition, like this. Now, we will turn on the CRO. Turn on CRO, and then let's say, since we calibrate already, we calibrated already the CRO, then we will turn on also the digital multitester. Then, of course, the range should be 20 alternating current. Then we will turn on also the function generator. Take note that in the function generator, after turning on here, you need to consider also the output here. Output. Then we just focusing on the equivalent sine wave here. Okay, sine wave. Then, so the frequency, for example, let's say 1 kilohertz here, and then for the amplitude here, so as much as possible should be visible for us. Visible for us in our reading. For example, this is our first reading. So first thing to do, focus on the CRO. In this CRO, so from the position, because we want to get the amplitude, we will focus it in the center location. So as far as the amplitude is concerned, we will measure from here. So per division here, we will focus first the voltage per division. The range it is 2 volts per division. You will see here the 2 volts per division. So in your data, you will see that there is a voltage scale volts per division there. Then the volts per division, it locate with in equivalent of 2 volts per division. So write it here, the equivalent to. Then the number of division of the voltage maximum here, voltage maximum, you will start from here. You will count 1 and 2. So meaning, okay, 2 from here, 1 and 2. So 2 times 2. So you can now compute the voltage maximum from CRO, which is equal to 2 times 2 is equal to 4. Divide by square root of 2, it is equal to 2.78. So if we will compare to the reading from the digital multimeter, it is also approximately the same. So 2.78, and here it is 2.77. So it means our calculation, the measured value, and then calculated value, it is the same. Then we will proceed to the next procedure. How to get the frequency? That is the next procedure, because this is first reading for you to, this is an example of a first reading. The time scale, second per division from CRO, which is zero point 0.5. We have 0.5 millisecond. What does it mean? The 0.5 millisecond, it means in scientific value, that is 5 times 10 to the negative 3. Then multiplied by the number of division of one cycle. What is the one cycle here? So considering that here, from here, the one cycle, it is start from here, going here. So the one cycle, we will focus on the equivalent center here, like this. So starting from here, going there. So with respect to x-axis. So this is 1, this is 2. So it means the time per division, which is zero point 0.5 times 10 to the negative 3, multiplied by scale per division, we have equivalent to 2. So therefore, zero point 0.5 times 10 to the negative 3 multiplied by 2, it is equal to 1 millisecond, or 1 times 10 to the negative 1. Using the frequency here, as stated, it is frequency equal to 1 divided by time. So calculating this value or substitute the value, it is equivalent to 1 kilohertz. So as stated in our function generator, as you've noticed here in the function generator, our frequency, it is 1 kilohertz. So it means from the measured value, we have 1 kilohertz here, and then the calculated value here, we have 1 kilohertz. Meaning, we can say that the calculated value and the measured value, it is the same, so therefore, it is correct.